Example number 64, solve the following logarithmic simultaneous equation. The first one is log x to base y is equals to 5. The second one, log x to base 2 is equals to 2 plus log y to base 2, isn't it? So let us start with this first one. So the first one will be given log x to base y is equals to 5. This is by definition, isn't it? It is by definition. So by definition it means y is the base, 5 is the power. Then x is the corresponding number. So it means y raised to power 5 is equals to x. That is the first way of getting rid of the log, isn't it? The next way of getting rid of the log is, you do what? We do, there is base y, meaning you introduce log y to base y, because a log of a number to the same base is 1, isn't it? So after that, if you get rid of this coefficient, you get log x to base y is equals to log y, the coefficient becomes the power to base y, isn't it? So either side of the equation you have log to base y, single term, meaning you now ignore the log, isn't it? If you ignore the log, you remain with x is equals to y raised to power, you get the same thing, isn't it? Are we together? So the first equation we found that x is equals to y raised to power 5, number 1. We go to number 2, go to the second equation. So the second equation, you can see this is log to base 2, here is no, here is log to base 2, meaning everything must be log to base 2, isn't it? So we have log x to base 2 to be equals to 2 plus log y to base 2. So we have to introduce a log to base 2 here. Everything must be to base 2, isn't it? So we are going to have log x to base 2 is equals to 2. Then we introduce log 2 to base 2. That is 1, isn't it? Then plus log y to base 2. We are introducing log 2 to base 2 so that we have log to base 2 in each and every term, isn't it? So log 2 to base 2 is 1. We are doing that to ensure we have base 2 in each and every term. So the next thing is to get rid of the coefficient, isn't it? So we have log x to base 2 is equals to log 2 squared to base 2. This 2 becomes the power, isn't it? So that is log 2 squared to base 2. Then it is plus log y to base 2. Then the next step, we ensure we have one term on either side of the equation. Okay? So what do we have this side? Log x to base 2. Then here, if you factorize out log to base 2, this addition goes to multiplication, isn't it? So 2 raised to power 2 is 4, isn't it? 4 times y. So that when you type the log inside, the multiplication goes back to addition, because we know 2 raised to power 2 is 4. Are we together? If you take the log inside, your multiplication goes back to addition. So from here, because we now have log single term on either side of the equation, we can now ignore the log, isn't it? When it is only a single term on either side of the equation. So if you ignore the log, you remain with x is equals to 4y. So your second equation, x is equals to 4y, equation 2. So x is equals to y raised to power 5, x equals to 4y, meaning x is, the two equations are equal, isn't it? Are we together? So it means y raised to power 5 is equals to 4y. Is that okay? So what is this? You have y raised to power 5 minus 4y is equals to 0. So you have y into y raised to power 4 minus 4. You are factorizing, isn't it? Are we together? So either y is equals to 0 or y raised to power 4 minus 4 is equals to 0. And remember, when y is 0, then these logarithms are undefined. So it means when y is equal to 0, those logs are undefined, isn't it? So the solution does not exist when y is 0. So it means the solution will exist when we have the second form, isn't it? So we have y raised to power 4 is equals to 4 when we type for the other side, isn't it? So can you get y? Can you get y? Y raised to power 4 is equals to 4. That means if y raised to power 4 is equals to 4, remember 4 is 2 squared, isn't it? So for you to get y, you raise both sides of the equation to power 1 over 4. Because 4 times 1 over 4, you remain with y, isn't it? Then here you have 2. 2 times 1 over 4, you remain with a half. So y is 2 raised to power half. 2 raised to power half is square root of 2. So it means y is square root of 2. So what is x? Use any equation to get x. X is 4y. Or x is y raised to power 5. Same thing, isn't it? X is 4y. 4 times y, meaning it is 4 root 2. Or if you take root 2 raised to power 5, you still get 4 root 2. You substitute it in any equation. Are we together? So we found the two solutions. Y is root 2, x is 4 root 2. Is that okay? Hello? Yes. Good.